Good morning, everybody. Up to the last lecture, that is up to online lecture, okay? Up to the Friday, we have studied, we are actually start a chapter number 5, okay? That is heat, okay? And there are, we see some preliminary concept, okay? These things, latent heat of melting and latent heat of vaporization, okay? That point up to we are discussed in the online lecture, okay? But still today we will revise it, okay? Now from today our again video lectures are start now. So again in today's lecture I will revise all that things, okay? And then from tomorrow we will start next point. Up to half of the point we are studying, not specific latent heat of vaporization and specific latent heat of melting point. This point we are not covered. Actually we are studied only latent heat of melting and latent heat of vaporization. Meaning of this specific, that is also we are not discussed there, okay? So now that point we will say in today's lecture, okay? So there we are studied in that topic that what we know we can change the state of substance, okay? Solid to liquid and liquid to gas, okay? We can change the state of substance by simply providing it energy, okay, in the form of heat. As we supply heat to the solid, it will get converted into liquid, and as we supply heat to this liquid, then it will get converted into the gas, okay? So such a way that transformation, that is the state change place of any substance by supplying energy in the form of heat, okay? That part we are discussed in the last lecture. So there are one activity is given there, okay? By studying that we have to see this topic, specific latent heat of melting and specific latent heat of vaporization, okay? That activity also we are discussed, okay? In that activity, in one container they take some pieces of ice, okay? In one container they take some pieces of ice, okay? And initially temperature of that pieces, suppose that is how much, 0 degree Celsius or less than 0 degree Celsius, okay? Now so this state of ice is what, solid, okay? So we know as we supply temperature, as we supply heat to this ice, okay? So as we start to supply heat at that time, one thing again we will see that this ice start to convert into liquid, okay? This ice start convert into the liquid at 0 degree Celsius, okay? Look at 0 degree Celsius, what we are find ice, okay? But now as we supply heat, okay, we know as we supply heat, then temperature of that substance should be increased, okay? But now in this case, in case of ice, we will find that at 0 degree Celsius we are supplying heat, it start melting, still its temperature does not increase, okay? So whatever the heat we are supplying to that ice, that all heat get used to break bond between the molecules of ice, okay? We know in the solid state intermolecular force of attraction is much greater as compared to liquid and gases, okay? So first, if we want to change the solid substance into the liquid, okay, so first thing what we have to do, so there we know first thing we have to break the bond between the molecules of this solid substance, that is the ice, okay? Due to the supply of it, this solid ice get convert into the liquid, okay? So as we convert it liquid, okay, at that time we will find that what temperature, again all the water, okay, ice we convert into water, there is temperature also 0 degree Celsius. Okay, so there are what happen, we are supplying heat to ice, but still its temperature does not increase. Okay, we see generally if you give heat to some hot substance, then rising temperature is takes place there. But now in case of ice, what happen here? At 0 degree Celsius, when ice is there, means it is in solid state. At that time, whatever the heat we supply to this ice, okay, that all heat get used first to convert all ice into the water. Okay, so whatever the heat we supply at 0 degree Celsius, that all heat is get used to change state of substance. Okay, so look at both having 0 degree Celsius temperature, but state of substance get changed. Okay, so somewhat heat we require here, okay, to convert this solid into the liquid. Okay, look at temperature is same 0 degree, but we need to supply somewhat heat. Okay, so here look at the diagram represent this state. Okay, so look at this AB line. Okay, this AB line tells us that initially when we start heat, our time is 0 and our temperature is also 0 degree Celsius. Okay, still we supplying heat to this ice. Okay, so we will find that up to 4 degrees Celsius, so up to 4 minutes, sorry, in x-axis we take time, that is the minute. So up to first 4 minutes, what happen? Temperature remains same. Look at, we are still here continuously supplying heat, but temperature does not increase. Look at, temperature remain constant 0. Okay, so whatever the heat we are supply here, okay, in this AB line, okay, this is point A, this is point B. So up to AB line, whatever the heat we are supply to this solid substance, okay, that all heat get used to break bonds between the molecules of solid. Okay, and due to that supplied heat, here what happened? All solid substance, initially what happened here? Solid substance, that all solid substance from this path start to convert into liquid. Okay, and here at point B, all solid substance get convert into the liquid. Okay, look at, whatever the heat here we supply at a constant temperature, that get used to change state of substance. Okay, so here temperature is what, same. Okay, initially 0 degree, at point B after 4 minutes again 0 degree. So what is about the heat that we are supplying in between this path, in between this time? Okay, so whatever the heat here we supply, that all heat is get used to convert solid into the liquid. Okay, so at a constant temperature, look at here, temperature is same 0 degree. At a constant temperature, okay, whatever the heat we are supply here, that all heat is get used to break bond between the molecules. Okay, so all that heat get used to convert this solid into the liquid. Okay, so that heat is called as latent heat of melting. Latent heat of melting. So whatever the heat we are supplying in between this part, all heat get absorbed and that used to convert substance into the liquid. That is why it called latent heat of melting. Specific latent heat we will discuss, but that heat is called as a latent heat. Latent heat means what? Hidden. Okay, if we are supply heat, then we should have to show a rising temperature. Okay, but here what happened, that changing temperature we does not see here. Okay, so that is why this heat is called as a latent heat, that is the hidden heat. Okay, so now as once here, after 4 minutes, look at, all solid get converts into the liquid, means all ice get convert into the liquid. At that time, what happen? Now, as we supply heat, okay, then what happen? After 4 minutes, all ice get convert into the water. So after 4 minutes, as all ice get convert into the water, from that time, okay, whatever the heat we supply to this water, okay, that all be used to rise in temperature. Okay, here what happen? That all heat is get used to break bonds. Okay, now here bond breaking is finished. Okay, all solid get converted into the liquid. Then after from here, whatever heat we supply, that all show us rise in temperature of the substance. Okay, so look at that change you have to note here. Okay, first 0 to 4 minute, all heat get used, okay, to break bond. That is why we not see here the rising temperature. But after 4 minutes, what happen? All heat supply to the substance get used to rising temperature of substance. Okay, up to how much time? Up to the increased temperature up to 100 degrees Celsius. We know at 100 degrees Celsius water start to boil. Okay, now in between that some water get convert into the heat. We see 60-70 degree, there are also we see gas vapors. Okay, that is the water vapors. But now at 100 degrees Celsius whole water gets convert into the vapors. Okay, so here at 100 degrees Celsius, what happen? Water start to convert into what? Start to convert into gas. Okay, start to convert into gas. Okay, so this BC line show the path in between 0 degree to 100 degrees Celsius temperature of water. Okay, so as temperature rise up to 100 degrees Celsius, then again one thing we will see there. Okay, what? Look at, suppose this is line CD. Okay, so here we see at 100 degrees Celsius, as temperature reach 100 degrees Celsius, then what happen again? Water start to boil. Okay, water start to boil, but what happen? Temperature of water does not increase. Okay, whatever the heat we supply at 100 degrees Celsius, okay, we see here what happen? As all substance get convert into the liquid, at that time what happen? As we supply heat, due to that heat, what happen? Temperature of substance increase. Okay, but now here at 100 degrees Celsius, again the same cases happen here. Okay, what happen here? Again, as we supply heat to substance, due to that supply of heat, what happen? Temperature does not rise. Okay, it remain constant at 100 degrees Celsius. Okay, so look at, we are supplying it still at 100 degrees Celsius, but temperature does not rise. Due to that supply of heat, what happen? This boiling water get converts into the heat. Okay, look at here again, this liquid we boil up to 100 degrees Celsius. Okay, so at that 100 degrees Celsius, what happen? Its temperature does not increase whenever we supply heat. Okay, so but due to that heat, what happen? Again, that heat get used to break bond between the liquid molecules. Okay, so whatever the heat we are supplying above 100 degrees Celsius, okay, so all that heat again same like this. Whatever the heat we are supplying here, that used here to break bond between solids, same like here. What happened? Boiling water means liquid is boiling here, and if we supply heat to it, then that all supplied heat get used to convert all water into the heat. Okay, so again here temperature remain constant at 100 degrees Celsius, and at 100 degrees Celsius whatever the heat we still supplying, that all used to convert that liquid substance into the gaseous substance. Okay, so such a way that again what happened at 100 degrees Celsius, at 100 degrees Celsius we supply heat. Okay, that all heat used to convert the substance into vapor. Okay, that liquid into vapor. So the heat above 100 degrees Celsius, that called as a latent heat of vaporization. What? Latent heat of vaporization. Okay, so this case generally we see when solid get convert into the liquid. Okay, and liquid gets convert into the heat. Look at what happened here. Temperature remains same. Look at 0 degree. At 0 initially we take hot ice, that is a solid substance. At 0 degree it gets convert into water. Means what here? At a constant temperature we are supplying heat. Due to that heat, what happen? State of substance get changed. Look at same here. What? Here initially water is there. Okay, we are supplying heat to it, but temperature does not increase above 100 degrees Celsius. Okay, so the at a constant temperature, whatever the heat we supply here, that all heat get used to convert that water into the hot, here water vapors. Okay, what? Water vapors. So at 100 degree means constant temperature, whatever the heat we are supplied to water, that all heat get used to convert that water into the vapors, means liquid state to gaseous state. Okay, so here same cases happen here and same cases happen here, but what? Here solid gets convert into the liquid here, and here what happen? Liquid gets convert into the vapors. Okay, so look at what? Temperature remain constant, but state of substance get changed. Here what happen again? Temperature remain constant, that is 100 degree, but state of substance get changed. So here whatever the heat we are supplying in between 0 to 4 minutes, okay, so all that heat get used to convert solid substance into the liquid substance. That is why that heat is called as a latent heat of melting. Okay, and now here what happen? At a constant 100 degrees Celsius, whatever the heat we are supplying to this boiling water, due to that supply heat, temperature does not rise, but boiling water get convert into the water vapors. So at that 100 degrees Celsius, whatever the heat we are supplied to that substance, so due to that what happen? That boiling water gets convert into the heat. So that heat is called as a latent heat of vaporization, because water vapors are formed here by the boiling water, and here what happened? What? That is the latent heat of melting. Okay, so you have to remember these 2 points: latent heat of melting and latent heat of vaporization. Latent means what? Simply hidden heat. Okay, as we supply that hidden heat to that substance at somewhat constant temperature, at that time what happen? State of substance get changed. Okay, so now we have to see the meaning of specific latent heat of melting. We know the meaning of latent heat of melting. Okay, latent heat of melting means what? It is the somewhat amount of heat we have to supply at a constant temperature. Look at 0, it is a constant temperature. At that temperature, due to supply of that heat, what happens? That all solid substance get converts into the liquid, that we call latent heat of melting. Specific latent heat means what? We have to take specific amount of substance. Okay, so if we take 1 kilogram substance or 1 gram of substance, okay, 1 kilogram or 1 gram, that chart is given below there. Okay, if you take the 1 kilogram means the specific amount of substance, okay, or 1 gram substance, okay. So if you take the specific amount of substance and we measure the, suppose we take 1 kilogram of ice, okay, and we have to convert that 1 kilogram of ice into the liquid, okay. So whatever the heat we require here to convert 1 kilogram of ice or 1 gram of ice into the water, that amount of heat, that heat is called specific latent heat of melting. Similarly, we have to take specific amount of liquid substance, whether it is 1 kilogram or 1 gram, okay. So suppose that specific amount of substance we take, and if we measure whatever the heat we need to convert that specific liquid substance into the vapors, okay, so that heat is simply called as a specific latent heat of vaporization. Okay, so simply specific, meaning of word specific means what? Specific amount of substance here we have to take, whether it is 1 kilogram or 1 gram, that chart is given there. And also the different latent heats of melting and latent heat of vaporization, that is also given there for various substances. Okay, the chart also you have to see there. Okay, but we have to only need to understand the meaning of latent heat. Latent heat means what? Hidden heat. Look at here, hot solid means ice is there at 0 degree, and here 0 degree again liquid is there. So what is the main difference between here? Difference that we supply heat, and due to that heat bond breaking takes place between the solid molecules. Look at temperature is same 0 degree, but still here at 0 degree we will find ice also and water also. Okay, due to the application of that hidden heat, okay, that's we call latent heat. Okay, as we supply that hidden, that is the latent heat, due to that this solid get converts into the liquid. Here also boiling water has 100 degrees Celsius and vapor is also has 100 degrees Celsius, but still we supply heat to boil water. At that time what happened? Due to supply of that latent heat or hidden heat, due to that water gets converted into its vapors. Okay, so such a way that simply you have to understood the meaning of these words, like specific latent heat of vaporization and specific latent heat of melting. Okay, so this is all about today's lecture. Remaining part we will see in tomorrow's lecture. Thank you.